All right. Good evening, everybody. Uh, as mentioned earlier in our group chat, that today's session will be dedicated to blockchain, and we will not talk about cryptocurrencies and about how they work, but what we will talk about is about the blockchain technology in general and as a fundamentals of the blockchain, how it works, how it looks like, in order to make it clear to our participants. So, just a minute. Yeah. So, we will discover the revolutionary technology behind the blockchain, learn about the decentralization, peer-to-peer architecture, and their benefits. And we will dig deep, as promised, the group as well, toward reinvention of the internet. As you know, the invention of internet, just how the invention of the internet changed our world. So the reinvention of the internet is something really our current world situation is does look forward to know and acquire and like turn businesses into new reality. So let's start. My name is Zeynal Zeynalov. I'm from Azerbaijan. I'm graduate of Cairo University, Faculty of Economics and Political Science, with a bachelor degree in economics major and IT in minor. I have attended several programming courses in several countries, in Azerbaijan, United States, in Silicon Valley, School of 42, French-based school, as well as School of 42 in Kocaeli, Turkey. I'm a software engineer, have developed several backend applications through API in ASP.NET Core framework, as well as Node.js. And today I'm gonna share my bit knowledge in blockchain and its usage, its fundamentals, how it works, and so on, so forth. So let's get started. First, we'll dig through definition of the blockchain. So blockchain is a revolutionary technology that enables the secure and transparent recording of transactions across a decentralized network. So we will understand what are decentralized networks mean and what do we mention or mean by security, as well as transparent recording of transactions. So any transaction record keeping is like recorded or chained in form of blocks in a great database called distributed ledger. How it will look like, we will see in the next slides and understand its shape. So, why blockchain is significant? Blockchain technology holds immense significance in modern technology due to its ability to facilitate trust without need for intermediaries. As you know, in today's world, everybody of us are suffering from intermediaries in terms of let it be banks or notaries or any other lawyers. In creating the new reality through decentralized ecosystem, we through blockchain, we will get rid of those intermediaries. By leveraging cryptographic techniques and consensus algorithms, blockchain network enables participants to transact directly with each other in a secure and transparent manner. What does it mean? We will go through each of these terminology. What does it mean, the consensus algorithms, as well as cryptographic techniques, blockchain networks, participants who are nodes or miners, and so on and so forth. So I hope by the end of this session, most terminologies will be familiar to you. Okay. So. Right. So to understand decentralized systems, we should understand what are centralized systems. What are centralized systems, and then we will go through creating the parallels between two in order to differentiate them. So in order to understand one thing, it's better mirroring the information to get understanding of the other things. So centralized and decentralized system represent two contrasting paradigms of organization and governance, each with its own set of characteristics, advantages, and drawbacks. So we will dive through characteristics of each and understand what decentralized systems are greater for than centralized systems. So in centralized systems, it's the authority and control which is concentrated within a single entity or single central authority, like a central bank or central government. So this central entity dictates the rules, policies, and operations of the system. So how system should work comes from one central unit. Disadvantages of it and the advantage of it we will see on next slides. But in any ways, we should understand what are centralized systems, so to be able to understand the other part as well. In the contrast, the decentralized systems operate without central authority, utilizing peer-to-peer architecture. So peer-to-peer means in network like communication between network participants. If we look at from networking software or computer networking system, there is a central server for any accessible website, and there are clients who access to information through that central server and utilize or acquire information. And that client, that server serves or provides information based on request response channeling. But in decentralized systems, all peers are connected with each other, so they utilize or acquire information from several nodes or several peers simultaneously at the same time. As all of you are familiar with BitTorrent, for example, so the architecture or work process of work process of BitTorrent is based on peer-to-peer peer architecture. So, for example, whenever you want to download a huge sized movie or file from using BitTorrent, so you download different parts of in bit size information from different nodes of the same file. So each node has the same copy of the file, but it helps or supports you to download it faster and efficiently by grabbing from each one part of the information. So peer-to-peer architecture is helpful in this. I'm sorry, it just I would ask everybody to turn off the mute the microphone, please. If anybody has microphone opened, please just turn off. Thank you. All right. So through decentralization, as we talked about the P2P architecture, where we will be dive deeper into it, the decentralization are special with openness, censorship resistance, and continuous availability. These are crucial parts of decentralization rather than the centralized system. While the centralized system offer distributed data and enable micropayments, they also face challenges such as the lack of the central asserted token guarantee. These are disadvantages of decentralized systems, which are like engineers and organizations are trying to overcome and solve this issue. All right. So, characteristics of centralized systems. So these are characteristics of centralized system, as mentioned earlier: single point of control, hierarchical structure, top-down control, efficiency, and vulnerability. So what does all this mean? Single point of control, where centralized systems have a single point of control, usually central assertor organization, which holds significant power influence over the system. On the other hand, in decentralized system, there is a separated authority. So each node has its own independent authority. Decision-making authority follows the hierarchical structure with directives followed from top to down, as it's mentioned here as well. So the central authority gives divisions of its counterpart, and that way all power flows from up to down. Policies and rules are enforced uniformly across the system with little autonomy granted to lower level of participants. So as the lower as system goes down, as much the authority decreases, and efficiency in centralized systems highly efficient in terms of decision making and resource allocation, as directives are executed quickly and uniformly. So in this system, this is maybe solely the advantage of centralized systems in relevant with decentralized. But these all other things really make it hard to manage systems like we wish to build our future as in decentralized systems should do. However, centralized systems are susceptible to single point of failure, as the entire system can be compromised if central authority is attacked or fails. So imagine you have one server, central server, or one central bank, and all information are there, and with emergency case, like something happened, some information destroy it. So there is no other copies. Yeah, of course, we could think of like making backups and so forth, but this also creates a redundancy problem in centralized systems. On the other hand, characteristics of the centralized systems are distributed authority, consensus mechanisms, peer-to-peer interactions, transparency, and resilience. Distributed authority means like authority are distributed among all network participants. So there is no central system or access point where all clients just access in order to get information. There is a consensus between participants. Consensus mechanism, decision-making relies on the consensus mechanism where network participants collectively agree on the validity of transactions and state of system. So we should really understand well this part, but we will move how it works in the next slides. But this is the really main, one of the main mechanisms which makes decentralized systems really to be much more democratic. And all network participants coming to one consensus in validating certain transactions. So between a client A and B, if happens any transaction, so if somebody sends to someone the good and other pays in cryptocurrency, for example, and if that transaction happens, so if somebody from the network validates that transactions through several algorithms we will go through, and after that, the consensus mechanisms works in order to make all participants to agree in the trueness of that transaction, because each of them has access to that information and they can check the trueness of that. Peer-to-peer interaction makes it what stands behind the consensus mechanism is its ability to be peer-to-peer. The transaction occurs directly between participants in a peer-to-peer fashion, as I mentioned before, and it organizes the transparency. So it becomes much transparent to see how things move forward. Resilience in the centralized systems are inherently these systems are really inherently resilient to single point of failure because information are distributed in a network of peers. So if somebody fails, the copy of the same information is with others. Just imagine as like WhatsApp group, if somebody sent a message to the group, and then imagine he deleted it and showing that, but not deleted as to be deleted from every device, but on his own device. And if he wants to prove that he didn't send anything, for example, but the copies of his message are still resilient with other participants. So this makes the transparency and resilience work together. So what's important in centralized and decentralized systems are several aspects, and two of them are confidentiality and publicity. So in centralized systems, confidentiality tends to increase as system becomes more centralized, where you can guarantee the confidentiality. But in contrast with decentralized systems, they prioritize publicity over confidentiality. So the information should be public. Yes, of course, there are several transactions which could be in private format, but in that networks, in private networks, the consensus mechanisms work in different form as well. While centralized system may offer enhanced confidentiality, they often sacrifice security due to their reliance on a single point of control. So despite the confidentiality is high, but in terms of single point of control and the resilience issue and failure problem, security here is on the top risk. So if it fails, one center fails, so fail everybody. But in a decentralized system, they offer great publicity, allowing users to verify transaction and monitor network activity in real time. Publicity. However, as confidentiality increases in centralized system, publicity decreases. So they, as much centralized system make things confidential as public has less access on it. But in decentralized systems, it is vice versa. Confidentiality increases in centralized systems, but publicity decreases. And in decentralized systems, it becomes vice versa. Excuse me. So, in conclusion, while centralized systems may offer stronger security, but they sacrifice privacy in that issue. So, privacy and security in both systems. In centralized systems, privacy and security often goes hand in hand. The central authority controls user data and can implement security measures. But in decentralized systems, privacy and security are achieved through a combination of cryptographic techniques and distributed architecture. So privacy, however, the concentration of data in centralized system possesses privacy risks. User must trust the central authority to safeguard their sensitive information and respect their privacy rights. But sometimes, as we know from several social media platforms, that privacies of users sometimes under risk because those centralized authorities may use their data as in terms of data breaches and insider threats and so on. Even government surveillance is the case. Where in the centralized system prioritize privacy by design, blockchain technology employs encryption and pseudo anonymization to protect user identities and transaction details. So it is barely, despite information and transactions are publicly available, but the people and their data behind them are highly encrypted and are available only through several consensuses. And security issues also differ in both systems. I don't want to concentrate on these parts too much, and I hope this gave a bit understanding. It's introductory, just to make understanding of the difference between two systems and understand why blockchain is so important and why blockchain is called decentralized. So, role of blockchain. Finally, blockchain plays a pivotal role in facilitating decentralized network by serving as a trust layer, very important, that ensures the integrity and immutability of the data. So data is being integrated and immutable in blockchain. That's why it's called like blockchain, because it's like chain of blocks interrelated between each other. And in order to change anything from any middle block, you have to start from the end and till the reach of that point in order to make change, and then go move forward again, like making change. There are some risks related with this issue as well, where we will discuss about it while talking about the strengths and weaknesses of the blockchain. But the pivotal role is here its integrity and immutability. Through its transparent and tamper-resistant nature, like open and like resistant means like it can face any destruction, attack issues, and so on. Blockchain technology enables secure transactions and data sharing without relying on central authority. So the main thing here is peer-to-peer. Like there is no central authority, so information is distributed between the network participants in parallel and democratic way. So there is no central need to any central authority to trust and to ask approval and to move forward. All right, so we are talking about P2B since the start of our session, and definitely it's always interesting for our life, like what P2P architecture stands for, how it works, and we will move move forward just to discuss it as well. So just a minute, I will fix something. Right. So in this section, we will delve into fundamental concept of the P2P definition, overview, join and leave dynamics, openness and censorship resistance. So like we will explore the fundamentals of P2P, uncover network, and how it facilitates entry and exit of participants in blockchain ecosystem, and discover the P2P networks accessibility and resist the censorship. So, and to make it transparent. What's P2P? P2P architecture forms the backbone of blockchain network, enabling decentralized communications and interactions among participants. So you already have like the imagination how they are interrelated between each other, and unlike traditional client-server models, P2P networks distribute control among all connected nodes. So nodes means like clients. So each client is in its own at the same time server. So another client can just acquire from second client information and vice versa. So there is it becomes it fosters resilience, and it eliminates centralization of the process. How nodes are joining and leaving P2P network. So in P2P blockchain network, nodes can dynamically join or leave the network without disrupting its overall functionality. So there is a ledger a distributed ledger or network of blockchain, and whenever new nodes want to participate, it easily joins through several authentication issues, and whenever and as soon as it joins, it acquires like copy of the information to its own machine or let's say storage, and it becomes accessible to other new participants or all network nodes. And at the same time, they can easily leave the system without interrupting the system, and it makes no disruption to other participants. And this dynamic nature of the network resilience as an absence of the central authority means no single point of failure. Nodes can seamlessly rejoin the network after temporary disconnection and maintain the integrity of the system. The dynamics of joining and leaving the nodes contribute to robustness of the blockchain network by distributing control across multiple nodes. P2P architecture enhances network resilience and fault tolerance. So whenever any node leaves the system, as mentioned earlier, nobody fails access to overall information. Openness and censorship resistance of P2P. P2P networks are inherently open and allowing any participant to join and interact without restrictions. So anybody, that's the greatest nature of the decentralization and mainly the blockchain. This is where you feel the publicity of the access. Openness promotes inclusivity and democratization, empowering individuals to engage in P2P transactions. So as soon as you join, you start to serve as a server. At the same time, you start to utilize as a client in this P2P network. Furthermore, P2P architecture enables censorship resistance, as there is no single entity with power to control or censor network activities. So nobody claims that I am the king and I rule everything here, despite several issues, as will be mentioned sooner, as 51% attack or 51% governance of the network. But these issues also are being solved as well. Blockchain availability and transaction processing. So main will in next upcoming slides we will just explore what makes blockchain greatest in terms of availability and in terms of transaction processing. So any transaction happens between nodes, how that process is processed, okay, and how the ordering of transaction happens. These are very crucial information, and the importance of 24/7 availability makes it really desirable, because not every bank and even central, especially central bank or central authority, is accessible due to their nature of being created or served. But in today's world, we always want to acquire 24/7 service, and this makes really blockchain crucial. So 24/7 availability is crucial for blockchain network to ensure continuous operation and accessibility. Just imagine you want to acquire something, pay for something, and request something. So earn even something, in terms of being minor. So this availability makes it really true. Unlike traditional systems that may experience downtime or maintenance window, blockchain networks operate around the clock, enabling participants to transact and interact with the network at any time. So even some servers of central authorities that they like distribute notifications telling that, oh, we are sorry, there is a maintenance time, so there will be interruption between this and that time for in our services. So take into account. So this doesn't happen in blockchain. How transaction processing happens, or process of transaction processing. Transaction processing in blockchain involves several key steps, including validation of the transaction, consensus, and block creation. When a transaction is initiated, it undergoes validation by nodes on the network to ensure its legitimacy and adherence to predefined rules. So as name suggests, as name mentions, the blockchain is like chain of blocks, but how those blocks are created, we will see in the next slides. So we will understand what block looks like, what block consists of, and how that block is created, and how that block is validated and attached to the whole previous chain and shaping another additional part or block in that total blockchain database. And that process will be understood in next slides. And for processing, we have transaction processing, we have consensus mechanisms, like as called proof of work algorithms, proof of stake algorithms. These are two of several famous algorithms available in blockchain, just to make it happen, to come into one consensus that validating of the blockchain and transaction is true, and after that putting that block into the chain of block. So transaction ordering. So transaction ordering is a crucial aspect of blockchain technology. So determining the sequence in which transactions are recorded and added to the blockchain. This process ensures that transactions are processed accurately and securely, maintaining the integrity of blockchain. So any block prior to be added into the blockchain passes through several processes of like record keeping, validation, hashing, and so on. So making that block to become pure and secure and integrated and true. And there are mechanisms of consensus. So as I mentioned earlier, blockchain network rely on consensus algorithms to achieve agreement among network participants on validity and order of transaction. So if somebody tries to make transaction, that transaction immediately does not create a block and adds it into the chain of block. No, if somebody intends to make any transaction, he just shows his intention and enters details of the transactions and pushed it to the network. So miners, those famous miners, which are very familiar to us, and we always hear about the Bitcoin miner or blockchain miners. But those miners, through special algorithms, which one of them is proof of work algorithm or proof of stake algorithm or practical Byzantine fault tolerance, through one of these algorithms, just solving complex mathematical puzzles, they find out information inside it, hashing number, and they validate transactions trueness. So after that, it like published it onto the network, and after coming to consensus of its validity, it starts to be added or attached to other chain of the block. Factors influencing transaction order: transaction fee and transaction size, as well as the priority rule. Of course, transaction timestamp is crucial. All those informations are creating shape of the block. How block looks like, which parts consist of, will be discussed in next slides. But this information is also important. In many blockchain networks, transactions with higher fees are prioritized for inclusion in the next block. So if block is interesting, so miner will acquire much more higher fee. So they just prioritize this block to be solved and finished and attached to the block. So they are prioritized based on transaction fee. And transaction style: larger transaction may require more computational resources to process and validate, and potentially affecting their priority to be queued. And priority rules also make it more manageable. By the way, this information, this academic information, will be shared with all of you free of charge, and it will be just presentation link where you can explore all information from there and read more and take notes and turn back. So just take into your account. Examples of transaction processing. So popular blockchain networks such as Bitcoin or Ethereum employ transaction processing mechanism that showcase the principle we have discussed before. In the blockchain network, for instance, transactions are validated by miners through proof of work consensus mechanism. So what is proof of work, how it works, we'll understand in next slides. And miners compete with each other to solve complex mathematical puzzles to validate the transaction. So whoever first completes that complex mathematical puzzles, so this needs computational power. That's why mining computers are so powerful, so enhanced in order to be able to solve these problems. And after solving that puzzle, they have access to transaction information and validate that information, because solving puzzle means validating the transaction. As soon as they validate the transaction, that block is added to whole blockchain, and miners acquire small coins in terms of Bitcoin. Similarly, Ethereum utilizes proof of work mechanism for transaction validation, with plans to transition to proof of stake model in the future. And there is a small difference between these two in terms of making proof of stake much more secure and reasonable. These examples illustrate the real application of transaction processing in blockchain network. So, blockchain consensus mechanism, the role of blockchain consensus mechanisms are ensuring the trust and security, validating and verifying the transaction, as well as securing data with cryptography. We will discover various consensus mechanisms used in blockchain, exploring critical role of nodes in validating the verifying transaction with the blockchain network, as well as learn how advanced cryptographic techniques protect data in blockchain. Finally, we see structure of a block in blockchain. It's oversimplified, and the block inside the blockchain, so one block out of all blocks of chains of blocks, consist of, in simple manner, from header and body. If you are software engineers or have some familiarity with this term, so even in Word documents, so you have the header part and you have the body of the information. So that's how block is consistent. So in header, we have block number or block height, a unique identifier for block with blockchain, timestamp, previous block, hash, Merkle root, and nonce. All these informations are crucial for any block, because these informations are used, some of them in consensus mechanism to validate the validity of the transaction as a nonce. Other are just for hashing, and hash of previous block in order to tie this block to the entire of blockchain. Okay, so block is created with previous blocks hash being inside. So each block has its own hash as well as hash of the previous chain, and that makes blockchain temper resistant, because if you destroyed one block and added another block, try to build the future blocks from that point, it will not work, because after reaching it will need the hash of previous block, and hash of previous block should be created based on a transaction. And body consists of list of transactions, sender and receiver address, transaction amount, transaction ID, and digital signature. So on header part, you have certain information, and in body part, you have transaction information. So list of transactions, you might have one transaction or several transactions under one block. For instance, the actual data stored in the block, typically representing transaction initiated by network participants. So if two or several counterparts have agreed on making certain transaction, and all those transactions are united under one block, so it creates a list of lists. And sender and receiver address identifies, these are identifiers for parties involved in each transaction. So for instance, one sends image to another participant, and another participant sends as an exchange, mean of exchange, the cryptocurrency. So these two transactions are added in that block. So their addresses as well are added. Transaction amount, so quantity of cryptocurrency or data transferred in each transaction, and unique identifier for each transaction. So if there are several transactions, so ID for each of them, and cryptographic signatures that authenticates the transaction and ensures their integrity. So here we see like a sketch of a very simplified block. So this is how a block out of the blockchain looks like. So as you see, here is the block header, and here is a block body. So block header consists of block number, timestamp, previous block hash, for instance, Merkle root, nonce, and body has several transactions. So one transaction, sender is address one, receiver's address two. So as you see, as it is public as well as it is private. So it's in terms of very high privacy, like secures the privacy of transaction makers. Amount, so in here we see 5 BTC, and transaction ID and digital signature. All these informations are crucial in for next process where we should, or network participants should use in order to validate this block in order to make it true, and after consensus add it onto the blockchain. So great. If you just thumb up or give any reaction how total like our session goes, is it informative or not? Just if you share your thoughts on chat, will be much appreciated. Thank you. Let's move forward. So here we see a structure of block in the blockchain, a bit detailed form, despite it is called a detailed form, but it's not that much detail as it should be, but it has really much more information in it, as in terms of block size. The size of the block in blockchain can vary depending on the specific blockchain protocol and amount of data it can accommodate. Typically, block size are measured in bytes or kilobytes, and each block might has its own size. Block header, as described before, so Merkle root is a hash of all transactions within a block, forming a Merkle tree, providing efficient verification of included transactions, right? So this and this nonce are used as well as the previous block's hash in next step of validating this particular block. All right. Block body is, as mentioned, is a list of transactions, so where sender and receiver addresses are mentioned, transaction amount and transaction IDs, and transactions are the actual data stored in block, typically representing transactions initiated by network participants. Each transaction includes details such as sender, receiver address, transaction amount, transaction ID, and digital signature. Right. So next slide will show us that structure in a bit detailed form. So as you see here, you see the size of the block, block header, where those information, required information or must-have information exists. Then transaction counter, total number of the transactions. Here are two, so here it should be written two. Sender information or the sender data address, receiver's address, amount, and so on and so forth. All right. So illustration of a block within a blockchain. So as you see, this is a blockchain consisting of several blocks, and block, let's say number 101 or 101, it does look like this one. Just a minute. Excuse me, just. Okay, simplified block structure, proof of work hash works here. So Merkle tree hash. So this Merkle hashes all transaction here. So using proof of work algorithms, it solves this mathematical puzzle, finds out through Merkle hash inside which transactions are there. So it compares and validates that it's true. So it's oversimplified explanation. And then through consensus, it adds a block into this blockchain and puts validated sign, like just philosophical speaking. So it validates validity of the block. So how chaining mechanism does work? So chaining mechanism is a fundamental aspect of blockchain. So this is the chaining mechanism. So you have these blocks, and in order to chain or to put this block into the chain, you go through chaining mechanism. So chaining mechanism is a fundamental aspect of blockchain technology, ensuring the integrity and immutability of the distributed ledger. There's a step-by-step explanation of how chaining mechanism works. First of all, if we don't have the blockchain, so initial block is called genesis block, and that block is being created. So genesis block creation, the process begins with creation of genesis block, which is the first block in the blockchain. The genesis block typically has no predecessors and serves as the initial point of the blockchain. Block structure. Each block in the blockchain consists of set of transactions and block header, or transaction or body or header. In body, as we have seen, are transactions allocated, and in the header, other information. And block header includes metadata such as block number, timestamp, and Merkle transaction and hash of the previous block. How hashing works. So before adding new block to the blockchain, all transactions within a block are hashed using cryptographic hash function, famous function such as SHA-256. So using these algorithms or this hashing function, all transactions are hashing, are being hashed. The resulting hash, often called the Merkle root, uniquely represents the collection of transactions within a block. Then, after hashing, it reference for previous block by adding the hash of previous block into this block and making the chaining process to be started. So each block contains a reference to the hash of previous. Not each block has two hashes, one hash for previous block and second hash for its own block. And forming the by doing so, it forms the chronological sequence. This reference is included in block header as previous block hash. Then block validation comes into place. Before new block is added to the blockchain, it undergoes through validation by the network nodes. So miners or validators ensure that the block's transactions are valid. The block adheres to the consensus rules, and hash of previous block references in the header match the actual hash of the previous block in the chain. And then consensus mechanism comes onto the play. In a blockchain network, consensus mechanisms such as proof of work or proof of stake ensure that all network participants agree on the validity of the new block. So one node or one validator validates, but then other participants or other validators are coming onto a consensus that this is really valid block to be attached to a block based on the mechanism. Once a block is validated and accepted by consensus, it is added to the blockchain and continues the addition of blocks as new transaction occurs, and this needs to be recorded and created with the same order as listed through 1 to 6. And this creates immutable history in general distributed ledger. So this is a small illustration of the chaining process. So this is block 1 or first block, Genesis block. This is the second block, third block, and fourth block. So each block is added after each other. So as you see in here, it has an initial hash, so with 0. Here on the header, it has hash of the genesis. So hash of genesis is hashing of all included information, and after hashing, adding those information onto here. And the block 3 has the same relation onto block 1. So why it's written here hash of block 1? Because genesis block is considered zeros block, the block number. So this is despite it's here block 2, but its number is block number 1. So its hash is entered or added onto block 3 or block number 2, and so on and so forth. So excuse me. No. So here is the explanation. Each block contains a reference to the hash of previous block in the chain, typically included in the block header. When a new block is added to the blockchain, it contains the hash of previous block, ensuring chronological order and integrity. So to alter or change anything in this block, you should change everything here and then come make change everything here and come make change in everything here. And even those you can do it on your copy as a node, you cannot make this happen in all blockchains of other nodes. So that makes it its integrity or transparency being much more secure. This chaining mechanism creates a link between blocks and forming a chain where each block is cryptographically linked to its predecessors. So here are explanations of each block. The Genesis block, the first block in the blockchain, often referred to as the Genesis block, has no previous block, has block hash since it's the initial block, so its hash are 0. Block 2, 3, 4 subsequent blocks in the blockchain, each block contains references to the hash of previous block, creating a chain. Explanation lays here. Block 2 references the hash of Genesis block. Block 3 references the hash of block 2, and so on and so forth. This chaining mechanism ensures that any attempt to modify a block in the chain would require altering all subsequent blocks, making it computationally infeasible and maintaining the immutability and security of the blockchain. So as I told, even altering it requires much more computation power, and that is not enough because you should do it on each node's copy, which is impossible, almost impossible. So this is how chaining mechanism works or illustrated. The validation process passes through either the proof of work or proof of stake algorithms through solving complex mathematical puzzles. So how it works? Someone requests a transaction. So these are two parties. The requested transaction is broadcasted to P2P network consisting of computers known as nodes. So all nodes are getting informed regarding this transaction. So these transactions pass through validation process. The network of nodes validates the transaction and user status using known algorithms. A verified transaction can involve cryptocurrency. So as like reward of the job done, so cryptocurrency is being created. So that's why it's called mining. So through validation process, you are mining new cryptocurrencies. And once they verify, the transaction is combined with other transactions to create new block of data for the ledger. And it goes to be attached onto the chain. The new block is then added to the existing blockchain in a way that it's permanent and unalterable. The transaction is complete. So this is how it works. Cryptocurrency is a medium of exchange created and stored electronically in a blockchain using encryption techniques to control the creation of monetary units and to verify transfers of funds. Bitcoin, the best known example. Excuse me. Yeah. So proof of work algorithm, mechanism of proof of work. This is how the mechanism works. So here is a oversimplified uh, like illustration. Uh, Mining starts and the node solves the puzzle, validates block, and adds it to the chain. Proof of work requires network participants known as miners to solve complex mathematical puzzles to validate and add blocks to the blockchain. These puzzles are computationally intensive and require significant computational power to solve. The first miner to solve the puzzle earns the right to add the next block to the blockchain and is rewarded with cryptocurrency. The key features are security, is the transfer or can be correct somehow. Is that what it does? Encryption gets lost in between the transfer. No, encryption, there is a really complex and hard process or algorithms, and everything is calculated. So there is a question that is, does encryption gets lost in between? No, definitely no. And tracking of this is almost impossible. Security, decentralization, and energy intensivity. These are three main key features of proof of work in terms of or in regard, in contrast with proof of stake, where proof of stake is energy is not energy intensive. So security proof of work relies on computational power of miners to secure the network against attacks. And decentralization, anyone within with the required hardware can participate in mining process, promoting decentralization. And mining consumes a significant amount of electricity due to computational resources required to solve this puzzle. Excuse me. Yeah. So algorithms are really like highly secure. So in order to manipulate and to change, to alter it, there are some risks, but it is almost impossible. And even one fails, one node fails, another node starts to solve the transaction and offer it to consensus approval. So all other nodes start to use same techniques to solve it. So if all come into one consensus, they validate and approve and allow the block to be added onto blockchain. Proof of stake selects a validator, so this is much more powerful option and algorithm. So it selects a validator to create and validate new blocks based on amount of cryptocurrencies they hold and are willing to stake or lock up as a collateral. Validators are chosen through deterministic algorithms that considers factors like validator stake and coin age. Of course, for misusers, this algorithm might work on to hand, but taking into account the peer-to-peer form of the blockchain, so it is almost impossible, because all network somehow, or main part of network, should agree onto making some changes. Validators are rewarded with a transaction fee or newly mined mint cryptocurrency for creating a validated blocks. This, in some cases, this proof of stake algorithms might be not that democratic, as whoever has much more coin, those will be selected as a validator. But anyway, this is one of those algorithms. But in modern age, several algorithms are implemented at the same time in order to make the decentralization and democratization of the system become true. Okay. Key features. This is energy inefficient, and security really relies on economic incentives, where validators have vested interest in maintaining the integrity of the network, and this algorithm consumes significantly less energy compared to proof of work, since it does not rely on computational power and centralization. Here is concerned. Like, critics argue that proof of stake may lead to centralization, as validators with larger stakes have more influence over the network, as I mentioned earlier. There are several questions I will try to answer at the end of our session. So let's move forward. So we passed on to distributed ledger concept. Distributed ledger is the decentralized database that is spread across multiple locations or participants in a network. Each participant maintains a copy of ledger, and updates to ledger are independently validated and agreed upon by consensus among the participants. Here is a detailed explanation of distributed ledger and its role in blockchain. So distributed ledger is like a great database where block nodes are united, having their own copies of blockchain. A distributed ledger is a decentralized database shared across multiple participants or nodes in a network, unlike traditional centralized database, where a single authority controls data storage, management, and distributed ledgers. Distributed ledgers distribute data across network of nodes. So here is like a simplified image. So this is, imagine, is a distributed ledger. So we have node 1 with block chain. Okay, so node 2 has the same content over here, as you can see, block 1, transaction, sender 1 and 2. So this same copy of node 1's blockchain is also here and here. So whenever any new node is connected in distributed ledger, he will grab for himself one copy of this blockchain as well, and creating greatest decentralized database. And whenever one node is going out of the distributed ledger, all other nodes are still maintaining their own copy. So each node maintains an identical copy of the same ledger, and changes to the ledger are propagated to all nodes in networks through consensus mechanism. So whenever new block is added to main blockchain, so that update through consensus mechanism is being updated for all nodes. So by that, maintaining the integrity and transparency of the blockchain. Roles of distributed ledger in blockchain. In the context of blockchain technology, the distributed ledger serves as the backbone of the blockchain network. Each block in a blockchain contains a set of transactions, and those blocks are linked together in a chronological order to form chain. A distributed ledger ensures that all transactions are recorded and stored in a secure and transparent manner across all nodes in a network. Participants in a network can independently verify transactions by referencing the distributed ledger, eliminating a need for a central authority. Consensus mechanisms such as proof of work and proof of stake ensures that all nodes in a network agree on a validity of transactions before they are added to the ledger. The centralized and distributed nature of ledger enhances security, resilience, and trust in blockchain network. So in the sketch, as we have seen, the distributed ledger is presented by multiple nodes, each maintaining its copy of ledger. Each node contains block of transactions, and changes to ledger are replicated across all nodes, ensuring consistency and reliability. So having every node store a copy of blockchain ensures the decentralization and the transparency. So blockchain network utilize this distributed ledger, and each node, as mentioned earlier also, has its own identical copy of entire blockchain. So regarding the security, with the multiple copies of blockchain distributed across nodes, the network becomes more robust and resistant to tampering or manipulation. Any attempt to alter the blockchain on one node would immediately detect it and rejected by the rest of the network. So this is the answer to last question. And to manipulate distributed ledger is impossible, because distributed ledger is like a greatest network of those nodes. So imagine these nodes are interconnected with each other. So to change copy of distributed ledger means to change copies of blockchains in all nodes. So that's impossible. Okay. All right. I think this is too much information today. So after distributed ledger, we are passing to a new concept or new information regarding IPFS. So as you have seen or understood, the nature of information here is provided in terms of starting from a single block and information inside the block up to blockchain and distributed ledger and addition of IPFS connected with blockchain network, creating new reality or reinvention of the internet. So what's IPFS? It is, as the name suggests, it is interplanetary filing system. So yes, you understand well, it is intended to serve as a filing system to send information between planets. So our great minds think that in the future we will send information from the Earth to the Mars or Moon. So really from now we need this system to be on place. So now what's IPFS? Interplanetary filing system is a decentralized protocol designed to create a P2P method of storing and sharing hypermedia in a distributed file system. Sorry. Yes. If blockchain is intended to store transaction data, interplanetary filing system, as name suggests from filing, stores and shares hypermedia in a distributed system. It's intended to serve as a replacement for traditional client-server model of the internet. And here is the explanation how it works. It mainly addresses the content, unlike traditional web URLs, where content is located based on the server's address. So, for example, if you want to access a certain image, so you should go through URL mentioning the name of domain name, which is through DNS tied to the IP of the machine. So through IP of machine, you go onto certain partition, certain drive, under certain drive, certain folder. Inside the first certain folder, you go to certain file. Here, everything works in another way. Each piece of in IPFS, each piece of content is assigned a unique cryptographic hash based on its content. So this hash becomes its address in on IPFS network. So any data becomes unique in IPFS. So you will not be able to find another copy of the same image in the network. You know, in order to access the image, so you will need to have the certain address of that image or content address. So not like URL, but same cryptographic hash. So this solves the greatest problem of the current internet, which is called the double spending problem. So you will not have a copy of same image distributed over several machines or peers. Decentralized storage. Content on IPFS is stored across a network of nodes rather than on centralized server. When a user requests a content, IPFS protocol locates it by searching for nodes containing content associated with its hash. Data deduplication. So since content is addressed but by its hash, identical pieces of the content are only stored once on IPFS network. This reduces redundancy and optimizes storage space. P2P networking. IPFS utilizes a P2P networking where nodes cooperate to distribute and retrieve the content. IPFS and blockchain relationship. So immutable content, decentralization, integration. In terms of these ideas, we will explore. Like blockchain, IPFS aims to create a system where data is immutable and tamper-proof. Once content is added to IPFS, its address or hash is derived from its content, making it practically impossible to alter the content without changing its address. This immutability is similar to how transactions are recorded on blockchain. Both IPFS and blockchain technologies aim to decentralize the internet, while blockchain decentralizes transactional data storage and validation. IPFS decentralizes the content storage and distribution. They complement each other in creating more resilient, censorship-resistant, and privacy-preserving internet infrastructure. Blockchain applications often require the storage of large files or data off-chain due to scalability and cost concern. IPFS provides an ideal solution for storing these files in a decentralized manner. So this is just oversimplified image how blockchain and IPFS work all together, creating new reality of Internet 2.0. So file is put to IPFS. IPFS return hash file. This is like added to smart contracts through public key, and at the same time it distributed through split it into n shares randomly choosing the special keys and encrypted, and encrypted data are stored on blockchain. Okay, sorry, just sorry, I'm just clicking always escape button, and that's why. All right. So, yes. This is how another example works. So, image is the oversimplified relation between IPFS and blockchain. So, file the transaction, user A sends coin to user B, and file is stored, acquired file through a hash function turns in fingerprint and turns into block of blockchain, and the file itself is stored. So information about the file sits here, and file itself sits under IPFS through distributed hash table, right? So this is new planned way of utilizing internet. So IPFS network and blockchain. And this section represents the interplanetary file system network where content is stored and accessed using content addressing. In blockchain, in blockchain, this section represents this section of the blockchain, represent where transactional data is stored and validated and decentralized manner. Blockchain networks rely on consensus mechanism. Already we have learned about it, to agree the validity of transactions. So it is really important to know that the validity of the data is highly secure, and it's almost impossible to destroy it. IPFS and blockchain networks are complementary technologies. While IPFS provides decentralized storage and access to content, blockchain network provides decentralized validation and consensus for transactional data. They can be integrated to leverage the benefit of both technologies, such as storing large files or data off-chain using IPFS, while recording their hashes on blockchain for verification and integrity. Double spending problem. Double spending problem is one of the main problems in internet. So in interplanetary filing system, IPFS plays a complementary role into blockchain technology and addresses certain aspects of double spending problem, particularly in terms of data integrity and content distribution. So in order to, as I mentioned before, to save, to secure the copies of certain files, so you really needed more than current internet. And in that terms, IPFS came into the play. However, it's important to note that IPFS alone does not directly solve double spending problems related to digital currencies and assets. Roles of IPFS in double spending problem, and we will see roles of blockchain as well. So IPFS provides a decentralized and immutable method of storing and sharing data, content addressing, and content distribution. All this, like mentioned previously as well. So IPFS facilitates efficient and resilient content distribution by leveraging P2P networking. While IPFS contributes to data integrity, so double spending problem associated with digital currencies are solved by blockchain. So blockchain technology with the centralized ledger and consensus mechanisms remains a primary solution for preventing double spending in digital transactions. Reinvention of Internet or Internet 2.0. In context of Internet 2.0, blockchain and IPFS are likely to play complementary roles in reshaping digital landscape. Decentralized infrastructure, trust, transparency, P2P economy, new paradigm of interactions are main addresses, points of addresses Internet 2.0 should solve. So Internet 2.0 is expected to embrace decentralized infrastructure where blockchain and IPFS work together to provide secure, resilient, and censorship-resistant services. Blockchain enhances trust and transparency by providing a verifiable and mutable record of transactions. IPFS complements this by offering decentralized data storage and retrieval. P2P economy. Reinvention of Internet may foster a P2P economy where digital assets, contents, and services are exchanged directly between users without need for intermediaries. So this is one of key points where current Internet without intermediaries cannot solve. And Internet 2.0 could usher in a new paradigms of interaction where users have greater control over their data and digital identities. Blockchain-based identity solutions and decentralized social networks could integrate seamlessly with IPFS. So, for example, in social media like Facebook or Instagram, data of users are used in terms of earning money for those centralized entities as social media owners. And despite users' data are used to earn money, but those users are not rewarded or paid for that. Only social media owners, media network owners are earning. But in this case, even those data owners will be able to earn and will be able to contribute in that. So they will decide, would they want to earn money and agree on sharing their data or not. So this is the new reality. And finally, blockchain in a real world. Here are some real world examples of blockchain implementation in various fields. So you can dig deep and dive search for those and see how they work. So fields are academic certification, supply chain management, government regulations, employee verification, trustless file sharing, health record management, digital asset exchange, social network, just voting system. And there are really real world like implementation of it. For example, for academic certification, Stone Global Education, in collaboration with IBM, developed a blockchain-based platform for storing and sharing educational records securely. So this platform enables students to access their academic credentials, certifications, and achievements immediately, enhancing transparency and eliminating fraud. Walmart, partnering with IBM, just implements the blockchain technology in its food supply chain. So, government of Estonia, for example, implements blockchain in its e-residence program. And employee verification. So Workday, just cloud-based human resource software company, introduced blockchain-powered platform for employee credentials verification. Trustless file sharing. So Filecoin. Filecoin leveraged IPFS in a decentralized way in order to store files and through network storage that allows users to rent out their unused storage space and earn cryptocurrencies in return. Just imagine you have Google Drive, okay, let's say free of charge, but Google Drive belongs to Google and Google is centralized body, right? But in this case, if you want to save your files, for example, you can use Filecoin, who leverage free space of network participants, all right? They're separating some shares, some partitions from their storage and providing it in very cheap manner to other users. Storage is also one of the same trustless file sharing system. Medical chain and Binance is one of the world's largest cryptocurrency exchange, facilitating the trading of various digital assets. So just imagine those digital assets are unique and you exchange them onto cryptocurrencies, and leveraging blockchain is very crucial here. Steemit is another social media platform that rewards users for creating and curating content. Just imagine, by leveraging blockchain technology, Steemit provides a decentralized and censorship-resistant alternative to traditional social network, where users have more control over their data and can earn cryptocurrencies for their contribution. And even if, for example, you agree to receive marketing posts or advertisement, you will earn for that. Of course, Stimit also will earn, but they will share it with network participants. All right. So this is how blockchain technology works, like oversimplified illustration of blockchain implementation in educational fields. So learners complete exam, teacher writes exam results in local DB, and so this system, overall system, assigns learners IDs, and smart contracts are here in distributed ledger come onto place. So imagine this data in the institutional education institution is written onto blockchain, and it works through smart contracts which checks for their answers. So if they pass the system, so it is shared with enterprises. So whoever has access to here, they will see the real result of learners. Of course, blockchain has its strengths and weaknesses. Regarding the strengths, we have talked, but main point is weaknesses, which is being addressed and solved. And one of it is large scale of blockchain networks. Another is energy intensive mining process and scalability challenges, and 51% of problem. So what's one of weaknesses is lack of central authority. So there is no central authority who decides to leverage the processes or govern the network, but this decentralization, while beneficial for security, but can also lead to governance challenges and coordination issues. So the nodes can act asynchronously or from out of central body. And token value concern. So another weakness of blockchain is violation and speculative nature of cryptocurrencies, which can impact the value of tokens and hinder their adaptation as stable medium of exchange. However, various solutions such as a stablecoin or governance mechanisms are being developed to address this concern. So manipulation on token value also might create another issue. And the 51% attack, 51% attack, the attack which is really significant security concern in blockchain networks, particularly that utilize the proof of work consensus mechanism. In POW blockchain, such as Bitcoin, miners complete the validate the transaction and add new blocks through this mechanism. However, in single entry or group of entities controlling more than 50% of network has ability to make change to total distributed blockchains. So that can potentially manipulate and change blockchain, which our friend asked during our session. So yes, and these issues really need to be solved, and great and bright minds are really working on this issue to solve the topic. So the evolution of the blockchain from Bitcoin to beyond, and scalability and interoperability solutions are still needed to be addressed. So blockchain creates the future of trust. It's decentralized governance, transparency, and this intermediation really worth more than solving those problems. And as soon as those problems will be addressed and solved, it will create more room to implement blockchain, maybe in all aspects of our life. So this is end of our session, and I hope it was interesting. And there are several questions. One of our friend addresses different questions. So if peer is connected, if a peer is a connection part, and how does the chain works? So chains are stored in different nodes, and all those nodes are under different distributed ledgers connected. So whenever any node is attending or joining the distributed ledger, one of them is Hyperledger, for example, they automatically acquire the copies of blockchain. Distributed ledger, one copy is stored, it can be manipulated, and the next can be no, it's not one copy, it is as name suggests, it is distributed. So it's not only one copy, and it is distributed between nodes, and the only connection to that network makes nodes to be connected through P2P and get their own copies of blockchain. The digital data is stored somewhere or needs a rest place to transfer its data to load without any store and rest network data, how it is transferred data files. So digital data is definitely stored in certain place, certain storage, and in IPFS it's creating a special address, that content, and at special place. And despite it is distributed between a network, but whenever you come to get the copy, you only get only one copy of that data. How can we stop scams? Whenever humanity is there, so scams should be addressed first through ethical ways anyway. But of course, the computational and algorithmic approach always should be developed. And for any scam, always there will be the solution. And for any solution, always will come new scammer to change. So it will be like under continuous development. But of course, it definitely will come to certain place where there will be no room in computational system to those scams. All right, so I hope you have enjoyed our today's session. Is there any way to know if a company you want to invest in this crypto Bitcoin, is it legitimate company? See, what regards regarding legitimacy of cryptocurrencies. So as you have seen, we didn't talk about the cryptocurrencies because we see blockchain more than cryptocurrencies, and cryptocurrencies are only one of those places where main scams and scammers are come onto place. So it is always controversial to approve righteousness of the process how those cryptocurrencies are mined and generated. But of course, there are other issues or other thoughts and ideas where really true cryptocurrencies could come into place. Those cryptocurrencies are thought to be human energy as a stored value. So we have some ideas regarding developing those concepts and putting those onto blockchain. So we think that it will solve too many global problems where humanity are being killed or destroyed. So in this terms, if we would be able to turn human energy into the cryptocurrencies, so the value of humans will really increase. And it will really increase the quality of the currency. So as gold plays a role in the economy, the birth of people and their development mentally, educationally, and their outcome onto the globe will really turn to a new idea of new generation cryptocurrencies. But this is thoughts and ideas, and we all should think about it. So this is idea for you all. Just if you have any thoughts or any contributions to do, so we can discuss all those in our group. So thank you very much for your time. We started 15 minutes later from actual time, just waiting for other group members to join. And we think it was really useful. And I'll appreciate your participation. And if you like it, just share your thoughts on group and have a good time. Thank you very much. Bye.